Hello dear students, good afternoon. Welcome to Sri Chaitanya, India's largest exam platform. As discussed, we will be discussing today the 25 must-know questions which are very important, and you can think of that if we will understand all these concepts, score, NEET, fundamentals, boards, everything will be very easy to you. Myself, Neeraj Agnihotri, your physics NEET mentor. See, today what we will discuss, I have extracted something like the very good concepts which are very relevant. If you will understand these things in a very good way, then everything seems very easy for you, And prior to that, let me have some words with the previous discussion that was very important, that whenever we solve any question, you have to mark your answer very accurately within 5 seconds, because 180 question for NEET pattern, 180 questions multiplied by 5 seconds, 900 seconds, and 900 seconds means simply 15 minutes. It means by hook or crook, you will spend 15 minutes in marking these questions. This is very important. Usually students consider this, sir, we didn't get time. Beta, only that time is deducted which we have marked. Yes. So let me start with what we are going with. We are going with a very strong cause for us, and what is that? Score exam. In the score exam, we will be having the cash rewards, 350 crore scholarship, NASA trips, then we are having the exciting gadgets, and even 100% up to we are having the scholarship. So it's a very great chance to get into the platform where we can achieve the dreams, we can achieve our goals, we can excel in our thoughts. So today what we will discuss, very important questions. So I will be solving very all the questions in a very slow pattern. So my strong advice to you all is take a screenshot of it, spend good time on it. We'll be solving each and everything right away. See. And exam pattern is there. You are with the syllabus. If you are just new to the channel, don't forget to put a bell icon on there. Subscribe the channel. Get every update with us. And physics, chemistry, botany, zoology. If you are watching this very first day, take a screenshot of it, because today's session is very important. Very relevant questions in which students think that, oh, that question was very easy, though the wording was a bit different. So I have picked some of the good questions which are especially make you to feel very nice, very good about the subject. See, and I have discussed and displayed this syllabus to you. So take a screenshot of it. Now let's move on to next. Again, don't forget to register. So exam dates we are heading towards 28th of September, 12th of October, and registration link is given in the description box. Enroll yourself immediately. So what is NEET Physics? This is a NEET Physics Power Surge, where we will discussing 25 high impact problems. Means I have tried in these problems that if you are new to this concept, when you will go with this concept, you will feel very good about it and it will be very easy for you. Okay, so let me go with the questions now. Let's start. Agenda of the session is there. 25 problems we will be discussing there. In this, I have done somewhere I have picked laws of motion, work power energy, momentum. So in a mix, I have taken all the questions so that we should be on the toes to think and rethink again and very accurately. And solutions and discussion will be there, and we will be definitely having some sort of formulas, means where we can think of that these formulas are very important, and that formulas we have derived because of these conditions. So conditions will be there. You will definitely enjoy today's session, and definitely will be having some recap and assignment for that too. Okay, so few of the questions I will be giving you 1 or 2 questions as a homework. If you find any problem in there, take a screenshot of it, send to us, we'll give you the solution for it. Okay, so let's start with this. Now, what is the concept? So what will be discussed today? Today we'll be discussing the basic concepts in the mechanics to be there, and then how to approach the numerical analysis, because 25 high level questions we are supposed to discuss, and definitely beta we are going for the numerical analysis also, some calculus method. Immediately we are having these questions, and then the graphical methods. I have pasted one graph, it is very nice and it will be feeling very good about it. Okay, see, now there comes our mechanics score 1 dip. See, in this question, what is given to us? See, it is very simple question. You have studied, this one is x-axis, this one is y-axis, and it is given to you as this is the origin, this is a D point, this is a B point. Everybody is aware of this B point is the highest point. Everybody is aware of D point is the range for it. And I just want to make sure that you know this formula, and I do know that everybody is aware of. It is S is equal to what, bete? UT plus what? Half AT square. Am I right? S is equal to UT plus what? Half AT square. And here, you know, bete, acceleration happening to be the gravity, which is acting in the vertical downward direction. So what is the crisp of this question? What is the crisp of this question? In this question, I have treated UT as a one vector, half AT square as another vector. So I am just adding like this as one vector, and then I am adding this vector as another vector. So I am treating this as one vector, I am treating this as other vector. One vector means up to this vector, it is bete u vector t, and up to this vector, it is what? Half g t square, something like this. And I am getting this resultant. I am getting this as the resultant, which I can mark this as the displacement. So what is the best part of this question? Question says, a particle is projected at an angle of 45 degree with the horizontal, where AB and CD, they are parallel to what, bete? Y-axis, and B is given as highest point, and this point D is the point where it is going to hit the ground. Now see how to answer this question. I hope you have understood this idea, beta. S is equal to what? UT plus what? Half AT square. UT is there, half AT square is of prime importance, because in the question CD, AB, they are directly connected with the concept of what, beta? Half G T square. They are connected with the half GT square like that. Now let me explain this thing to you in a detail, and you will be finding this answer is very, very easy. You will be finding it very soon. And what is the best part? You are having this as a vector equation. You are having this as a vector equation. So what we are writing here? You are writing here S is equal to UT plus half AT square. And here U I treated, if gravity was not there, it was moving in this direction. If gravity was there, it was moving in this direction. So this will be our what, beta? Resultant. This will be our what? Resultant. So let's move on to how to solve this question. I hope you have understood this idea, everyone. Understood this idea, everyone? So let's solve this question. See. So I just want to recapitulate again, because it's a new concept. We are just with the NEET students. So I want NEET student must understand this in a very good way. So listen. This is a UT vector. Say this is a UT vector. This is what? Half GT square vector, and there you got the displacement. Nothing new. You are familiar. S is equal to UT plus half AT square. And here acceleration is what, beta? Gravity, which is acting in the downward direction. Now let me solve this question, and what is asked to me? B as a highest point and D as a point where the body has fallen on the ground. Now see, beta. So this journey which is given to us, beta, this journey which is given to us is for the time, because from O to B, how much is the time taken, beta? It is T by 2. How much is the time taken? T by 2, because it is the highest point. If you see, projectile is projected from there, it will take T by 2 time to reach here, and then from here to here, it will take time T to reach here. It means if I talk about this distance, it will be half G T by 2 square, beta. And if you talk about this, beta, now this distance will be half G T square, and this distance is what, beta? CD. This distance is what, beta? AB. And you can see in the question CD by AB is asked. So what is the value of CD, beta? what is the value of CD beta? It is half G T square. What is the value of AB beta? It is AB is equal to what? Is equal to what? Doesn't matter. We can write so what is the value of half GT square by AB? What is the value of AB? Half G T by 2 square. So when you solve it, you are getting that answer as 4, because that you can do half GT square will cancel out and this T square become 4. So answer become what? The 4. You can see the option 4 is there, which is our option. Answer is I have marked here. I think idea is very clear. Was it very simple? Was it very simple? Yes. Yes. Good afternoon. I think it's very simple. It's very simple thing. I want you should not miss this idea, because with this idea you can solve vector problem, especially when you are dealing with the kinematics. Wherever rain-man problem is happening, river problem is happening, you have to use the fundamentals of the vectors. It's very important. I think it was very simple. You have seen it hadn't taken too much time. We discussed S is equal to ut plus half at square. Ut is a that vector where the body was projected, and half at square means gt square was that vector acting in the direction of gravity. So when we compiled ut and half gt square, that become the resultant vector, which we call resultant vector, and here it is what? The displacement vector. I think idea is very clear now. And what is the value of B? What is the value for B? It is for half time. What is the value of D? It is for the full time T. I think idea is very clear, but B is for half time and D is for full time. So I have taken CD by AB is equal to what? Half GT square by half of G T by 2 square. So we are getting that result. I think idea is very clear. Very simple idea. So let's move on to next question. Now this is also very amazing question. Very amazing question. I have opted those questions today, beta, for you, in which very fundamentals are applied and very strong advice. You must note down the answers, okay, along with me, so that you can understand each and every concept thoroughly. And I will assure you, once you go with these 25 questions which we will discuss today, I will assure you, you will be definitely getting scholarship in the score exam, and you will be definitely cracking the final NEET, and definitely I will give you the ticket for NASA also, okay? So, see, now this question is there. What is this question? Like, it's very simple. What is there? He said, you have to take a screenshot of it, and we will be solving this. See, this force F is there, and you have applied the force F, and question asked is like what? A block of mass M, which is being pulled on an inclined surface, which is having a coefficient of friction, what? Mu is equal to what? 1, and the angle of inclination that is given to you, it is what? 30 degree with the horizontal, such that external force you need to apply at some angle, but it should be the minimum force. Why he is saying minimum? So that we can hold it, we can pull it up in a very gentle way, and we need to see what is the angle beta. What is the angle beta? This is what we have to calculate. Now it's very simple thing, but very simple thing. What is that? Listen very carefully. It's very simple, I tell you, very simple. Draw the diagram, we can crack. 100% we can crack. See, draw. Have you drawn? Have you taken a screenshot? Take the screenshot and let's solve. See, this one is F. So what is this value today? It is F cos beta. Now you are tending to pull this, you tend to pull this block in the upward direction. So where you are expecting the friction? Downwards, am I right? And where the weight component is acting, it is what beta? mg sine theta. I think everybody is aware of this thing, so I'm just keeping it in there. And this thing, this is what? mg cos theta. And we are expecting the normal reaction here, beta. This is what? The normal reaction. Am I right? Now listen very carefully. Listen very carefully. See. You can see friction is acting, beta, in this direction. Friction is acting in this direction, beta. This one is what? mg sine theta. F cos beta along the plane in the upward direction. So let me write my result here. I can write F cos beta minus friction minus mg sin theta, that is equal to 0, because this block is at rest. This block is at rest. And if I write second equation, which is normal reaction plus what beta? This was F cos beta. So component of F in this direction is what beta? F sin beta. So beta, I can write N plus what? F sin beta, and in the downward direction it is what? Minus mg cos theta, which is equal to what? Which is equal to what? 0. Which is equal to what? 0. Why? Because this block has not moved anywhere. Am I right? So if I am writing this question, so I need to calculate F. So what should I do? And I do know a standard relation for the friction, which is always mu n, which is always what beta? Mu n. I think idea is very clear. I think idea is very clear. So what I am writing for n, let me write n here. What is the value of n? It is mg cos theta minus f sin beta. The value of n. Mg cos theta minus what? F sin beta. That is the value of n. Am I right? So if you are getting the value of n beta, you can put the value of f here, and we can expect our result. We can expect our result f is equal to what? Mu n. So I can write, I just want you should write this way. See, there I am writing now f cos beta is equal to small f into what? Mg sin theta. Am I right? And what was the value of f beta? Mu n. So I am giving it to you that put the value of f is equal to mu n, and you put the value of f here. Now you will get the answer. So let me write the result here. What was that? We have written here f cos beta is equal to f plus mg sin theta. F cos beta is equal to what? F plus mg sin theta, first equation. And what is the value of n we have written? Mg cos theta minus f sin beta. Mg cos theta minus f sin beta. So let me help you out with the friction. F cos beta is equal to mu. What is the value of n? Mg cos theta minus f sin beta plus mg sin theta. I think idea is very clear. Idea is very clear. You know, we haven't done anything very seriously, anything in that way. Very simple approach, very simple approach. We have taken the component of the forces along the inclined plane and normal to the inclined plane. Am I right? So now listen very carefully. Let me keep this f cos beta on the one side itself. So we are adding f cos beta, and this was minus mu f sin beta. So I'll be keeping here mu sin beta is equal to what? It is mg sin theta plus what? Mu mg cos theta. Am I right? Because the purpose of this discussion of this question is you should understand the NEET 2025 pattern, where calculations were there, but they were very easy. They were very easy. So I want we should spend a good time on it. Okay. So what we are getting? We are getting this was mu, and let me write f here. So let me take f common in the bracket, cos beta plus what beta? Mu sin beta is equal to what? Mg sin theta plus mu mg cos theta. So there you have to see the value of f, which comes out to be beta mg sin theta plus mu mg cos theta divided by cos beta plus what? Mu sin beta. So since in the question it is asked external force is minimum. That is very important. External force is minimum. You know, you have calculated the value of external force, bete. You have calculated the value of what? External force. And that value is what? Mg sin theta plus mu mg cos theta by cos beta plus mu sin beta. So this is a variable. The denominator is variable with the beta. Am I right? And I just want to make sure that thing, you must understand this. Whenever some stuff like this is given, its maximum value, when you consider, is always the squaring getting of the coefficients. Am I right? And when you will calculate beta, so if you calculate this value, this tan beta comes out to be mu. Tan beta comes out to be mu. And if you want, I can solve it very quickly for you. Cos beta plus mu sin beta, because we need to maximize this function. If you take maximum value of this function, this will be the minimum value. If you take maximum value of this function, this will be the minimum value. So let me take the division beta. So d by d beta of cos beta plus mu sin beta. What is that answer beta? Minus sin beta plus mu cos beta is equal to what? 0. Because whenever we take maxima, we put that value equal to what beta? 0. So we are getting beta sin beta by cos beta as what? Mu. So here was, I have written this tan beta as what beta? 1. So tan beta is equal to, mu. And mu to me is given as 1. Mu to me is given as what beta? 1. So I am writing tan beta is equal to mu and beta is equal to what beta? Tan inverse 1. So what is tan inverse 1? That is very simple, 45 degree. So your answer for this problem is what? 45 degree. Option A is marked. I think idea is very clear. Very simple idea. We were having this, F was the force, beta is there, F cos beta, F sin beta, F cos beta, F sin beta, mg sin 30, mg cos 30, normal reaction. Am I right? And it was at rest. So we have just equated the equations, and very important beta, where usually students get stuck, don't forget F is equal to mu n. Don't forget this, because this is the parameter which correlates friction with the normal reaction. Done. So I hope you have enjoyed these two questions. These are very simple questions, very simple approach, very simple thought, but the only thing is you have to be very quick in forming this vectors, equations along the plane, normal to the plane, nothing else. Very simple. Done. See, now next question we see. Mechanics score dip 3. What is mechanics score dip 3? I have seen lot of students, they usually struggle with the concept of this block over the other. One block over the other, they usually struggle. But there is no way, there is no way you think of, sir, I am struggling in it. It is a very simple concept. I tell you, you just listen very carefully, note down very carefully, very importantly, and I want you should respond also in the comment section also, okay? And don't forget to like, subscribe, comment. Now, listen. So the question in which usually students get stuck, why they get stuck? Nothing to worry. Very simple approach, very simple approach. I tell you what is that approach now. See, now listen this thing very carefully. I am having a body here. Another body I have kept here. Am I right? When you are pulling this body like this, if you are pulling this body like this, so this body is experiencing the force of friction from this body in the backward direction. Very simple. Everybody is aware of. You have placed this body here. When you are pulling it like this, when this body will move like this, then it will face the friction in this direction. This body will face the friction in this direction. And third law says, this body, which was just under it, it will experience the friction in forward direction. I think idea is very clear. Now listen very carefully. Question comes, sir, why not we consider the downward body first, then we consider the upward body first? Now make a note of it. What is that? The note is wherever you apply the external force. The note is what? Wherever you apply the external force, first you have to see the movement, tending movement of that body only, where that body tends to move. You have to see this for the body on which you have applied the force. I hope you have understood this idea better. I hope you have understood this idea. Where the body has, we have applied the force. Now let me tell you very clearly. See, you have applied in the case 1, you have applied the force like this. In the case 2, you have applied the force like this. So let me have this diagram with you so that we can understand in a good way. Very simple. I just told, what is that? On which body you have applied the force, that is what you have to see. Am I right? Now listen. You have applied the force P here. So where does the normal action is acting here? The normal action is acting here, and also the normal action is acting here. Am I right? The masses of these two bodies are what? M only. When this body tend to move in this direction, so A will experience one friction here. You call it as right now F1, and this body A, because you are applying the force on A, so A is experiencing the friction from ground in this direction, and A is also experiencing the friction from B but in the backward direction, and you name it as F2. Am I right? Am I right? So in the next part, you can see it is connected like this. So tension will be acting in it, on it, this, and tension will be acting on there also, and tension will be acting on there also, and tension will definitely be acting there also. Am I right? And if I draw the, FBD, if I draw the FBD of the block P, if I draw the FBD of the block P, you can see you have applied a force P here, but you have applied a force F2 here. You have seen this. You have seen the force F1 here. You have seen the tension here. Am I right? This is for block A. And you have seen, I'm just, because I'm focusing more on the horizontal forces, so I'm not drawing the vertical forces. Though I need it, but I will be drawing bit later, so that we should understand the crisp of this question. And similarly, when you are going with the B body with it, so for the B body, tension is acting in this direction, you can see here. And if you are drawing for the friction, now see, on A, friction has acted in this direction. So on B, friction will act in the opposite direction, and its value will be definitely F2. F2. So idea is very simple. We were to calculate what? We were to calculate the force. In case 1, what is the value of the force P in the case 1? Am I right? So you can see with it here, P will be equal to T plus F1 plus what beta? F2. So what is the value of F1 beta? F1. So F1 is experiencing a normal action from A and B, and I know because fundamentals will be there with you beta. N1 will be 2 mg because this is M, this is M. So total normal action, the ground is giving it to the body A is 2 mg, and normal action getting by B from A is only its own weight, which is what beta? Mg. I think idea is very clear. Idea is very clear. So you can write the values here beta. So what we are getting the values? T is equal to what? F2, and F2 is nothing but what? Mu into N2. What is the value of N2? It is mg. So F2 you are getting what beta? Mg, which is nothing but T. So final answer there comes. Let me write the answer here now. P is equal to T. T is what? Mu mg plus what is the value of F1? Because F1 is experiencing mu N1. F1 is experiencing mu N1. And what is the value of N1? 2 mg. And what is the value of mu into 2 mg beta? It is 2 mu mg. And what is the value of F2 already you have written? It is mu mg. So this become what? 2 plus 1 getting what? 4 mg. Getting what? The 4 mg. So you can see one option is we are having with the 4 mg. So I am giving you 3 mu mg as a homework. I will draw the diagram friction here, F1, and there is no more tension, but since this body moves in this direction, so it will experience the friction from this side also in the adverse direction. Am I right? Am I right? So this one was what? F2. So P becomes F1 plus F2, and there it is what? T, and for body B, friction will be acting in the forward direction, and when you will solve, it comes out to be 3 mu mg. So for option for this question is A. That is there. I think, hope you have understood this idea. Very simple. You have seen it is bit calculative, but very simple approach. Very simple. Only one thing which is very important, I am repeating it again, that which body will experience the friction in the question? Only that body on which you have applied the external force, and you will see the motion of that body only. I hope you have understood this idea. Now let's move on to next. Now this is also very good and amazing question. Very simple. Block A of mass M is placed on a plank B, and a light support S is fixed on a plank B and is attached with a block A with a spring of spring constant K. Consider initially the spring is in the natural length. When the acceleration was not given, it was in the natural length. Now what happened? Plank B is given an acceleration. So what is the maximum? Beta, this is compression. What is the maximum compression in the spring? So you know it very well. When you will accelerate, this will experience some force in the backward direction. So it will move in the backward direction. Am I right? So if I write that, sir, if it get compressed by X, if this block is kept there like this, and what happened in there, that it get compressed by somehow some distance, you call it as X. Am I right? So what has happened? Why it get compressed? Because it has experienced a pseudo force MA. Now most of the students say, sir, how to consider the pseudo force? Very simple, bete. You have to consider yourself as if you are sitting in the system and it is being accelerated. So pseudo force we are writing because we are standing here and we are saying the system is being accelerated, so it is experiencing a pseudo force. Its mass is what? MA. If mass is MA and experiences pseudo force in the backward direction, since spring is being compressed, so it will experience the force in this direction. Am I right? So I will be writing this direction as what, bete? Kx. I think idea is very clear. So force acting in this direction is what? MA. Force acting in this direction is what? Kx. Why, sir, Kx is acting in this direction? Because block has moved towards the spring, so compression has happened. So when compression has happened in the spring will apply the force in the forward direction. So MA, this is Kx. So what is the value to be written? We know formula for net acceleration, bete. It is MA minus what, bete? Kx. F net is equal to MA minus Kx. So let me rewrite this format to write here. Just wrote MA, F net is MA minus what, bete? Minus what, bete? Kx. So when we are writing F net, what is F net, beta? Mass into acceleration, and acceleration can be written in terms of function mv dv by dx is equal to what? Ma minus kx. So what we are writing, you may take m here, v dv as ma minus kx dx. I think idea is very simple. Nothing happened, but dx multiplied with this. Now integrate. Now integrate. Listen very carefully. Where does the block was lying initially? It was at rest. Now when you pulled with an acceleration A, in the question what is said? In the question what is said? What is the maximum compression? Means when you have moved that with an acceleration A, it get compressed. So how much compression you are expecting? So when this word is used with a maximum compression, it means at this point also the final velocity will be what? 0. Final velocity will be what, bete? 0. So we are adding mv dv by dx. So what will be this integration? 0. Initial velocity was what? 0. Final velocity was what? 0. So there you call it as 0 to x naught, call it as maximum compression. So when you will integrate this answer, so we are getting MA integral dx minus, and let me equate because this is equal to 0 when you are equating. Let me write it directly as equating as 0 kx dx from what 0 to x naught. Am I right? 0 to x naught. So what we are getting, MA dx integration is 0 to x naught. This become k x naught square by 2. This x naught get cancelled. So we are getting our x naught result as 2MA by k. We are getting our x naught result as what? 2MA by k. So this was the answer. I think idea is very clear to everyone. Now again you see, it looks like, sir, this is very high level. No, it is very fundamental level, because you have done simple integration of this, putting these values of the limits. The only thing is you just have to have the fundamentals. That's it. Not required very high level calculations or very high level formulas. We don't require that. We just require the fundamentals. So what are the fundamentals we can apply? So there we got the value of x naught as 2MA by k, and you can see C option is marked 2MA by k. So this was your example number, mechanics dip number 4. Now let's dip more with a mechanics core dip 5. It is a very interesting question, Particle is moving along the elliptical path and with a constant speed. It's very important. When this word is noted, na beta, so my advice is note down this point on your notes. The constant speed is given. It means tangential acceleration is definitely 0 here. Am I right? So what is there? That constant, and as it moves from P to Q, what is the magnitude of acceleration is happening? So the only acceleration which we have to talk about is the centripetal acceleration. Only the centripetal acceleration. Now I think this point could be very new to you. See, whenever you are talking about that and centripetal acceleration in general given as v square by r, and he said constant speed and this constant speed means speed along the track. Speed along the track. He is not talking about angular speed, but he is talking about speed along the track, which is what constant. Which is what constant. I think idea is very clear. So what do we have? What do we have here? I have drawn this points moving there, this point moving there. So I have drawn two circles. One circle for this point, which is this white circle you can see, whose radius of curvature I have drawn R1, and for this point I have drawn this blue circle whose radius of curvature is R2, because you can see now it is very important. And why I have drawn? Because I have taken a small point and I have drawn a circle here. I have taken a small point, then I have drawn a circle here. This is the y fundamental point which I am discussing it to you, and you can see here radius is small and here the radius is large. Here the radius is small, radius is large, and centripetal acceleration is given by what v square by r. So AC is inversely proportional to r. So if r is more, AC is less. Here body has moved from P to Q. So initially r was less. If r was less, acceleration was more. Now gradually you can see the radius will be increasing. Radius will be what increasing. So it has reached to point R2. So radius has reached to the maximum value. So from minimum radius to maximum radius simply means from minimum radius to maximum radius. So minimum radius means maximum acceleration. So minimum radius means maximum acceleration, maximum radius means minimum acceleration. So continuously it has decreased. Continuously it has decreased because it has moved from point of minimum radius of curvature to the point of maximum radius of curvature, where tangential acceleration was 0, speed was constant, centripetal we have to tackle, AC is equal to v square by r, and r is called as radius of curvature. R is called as radius of curvature. So this was our mechanics dip 5. Done. So since I have done this question with you and radius of curvature I have asked you, so I have intentionally added up this question which normally NEET students usually skip that part, how to find the radius of curvature. I just want to tell you, in this year's NEET exam, there was a question, very first question, the 45, I think, code, and in that code, curvature was given, where radius of curvature you must be knowing. So I thought of to help you out for the derivation. See, how to solve this question? Our question is, which of the following represents the radius of curvature R of a curve y is equal to f of x? This is the question. Now, what is that question, bete? See, this one is x-axis, this is origin, this one is what? The y-axis. Am I right? Now, what happens is, you have drawn a curvature like that, and there you mark the point. And this length is basically ds. This is d theta, and this is what? R. So my advice to you is, if you are learning this idea how to find radius of curvature, you must draw when I am drawing. Okay? So see, this is, I have written d theta. So what is the value of beta ds? ds is what? R d theta. This is one point. And if I draw this as ds, this there, this is there. So this is what? Dx, this is what? Dy, and this is a right angle triangle. So what I can write for ds, it will be square root of dy square plus what? Dx square. So what we are getting with a ds, dx is what? Outside, and this become 1 plus dy by dx whole square, and what beta? Square root. Whole square into what beta? Square root. I think idea is very clear. One ds I have written for the curvature, and other ds I have written for dy by dx square plus what? Dy square plus dx square, just nothing but Pythagoras theorem. X-axis, y-axis, and we have taken ds. Am I right? Okay, done. Now I can put the value of ds here. So what I am getting for ds? What I am getting for ds? What I am getting for ds? I am getting r d theta, and this r is called as radius of curvature. This r is called as the radius of curvature. So r d theta is equal to what? R d theta is equal to, I am writing it as dx into what beta? 1 plus dy by dx whole square into what? The square root. So we are getting r is equal to what beta? Dx by d theta into 1 plus dy by dx whole square root. So I'm got this value of r. Very simple. Very simple. Now see the answer. Y, you know, it is a slope, and what is the value of slope beta? Dy by dx as what? Tan theta. Take the differentiation of this equation. So this will become d2y by dx square, and d by d theta of tan theta can be written as secant square theta into what beta? D theta by dx. Secant square theta into what? D theta secant square theta into what beta? D theta by dx. And what is the value of secant square theta beta? You know, 1 plus tan square theta into what? D theta by dx. Very simple beta. Not to worry about. And then this comes out to be d2y by what? Dx square. So I am using this expression for you. I want you should write. That is why you have to listen it very carefully. Done? Now final answer there is coming. R is equal to, this is d theta by dx beta. You can write dx there, d theta down. So you can write 1 plus tan square theta by the double derivative. Instead of this, 1 plus dy by dx whole square root by d theta by dx as what? This value in the denominator, am I right? Because it is written as dx by d theta. So it is written as 1 plus tan square theta. And tan theta, you know, tan theta is nothing but dy by dx. So this become dy by dx, square is happening, so I will be writing square by the double derivative. Am I right? With the mod, So if I am adding it up, so I will be getting, so my result as 1 plus dy by dx whole square raised to power 3 by 2 divided by mod d2y by dx square. I think idea is very clear. So that was the radius of curvature. Am I right? See, and the answer comes there as your answer. Option number A. So still we have finished dip number 6 only. Now let's go with the next dip. Now this is also a very good question. It will take time and it is also a very, very good question. Now what is that question? See. He says a boy is on a unicycle and in a circle of radius r is going, am I right? And the radius of the wheel is given as r and constant angular speed omega is given to you. And what is said with a actual acceleration of the alpha? Angular acceleration of what? Alpha. Of the wheel. Now I tell you one thing. See one thing. If you are having a body which is rotating like this, you are having omega in this direction. Body rotating like this, you are having omega in this direction. If you change its direction, omega is what? Angular velocity. Initially it was having this direction. When you rotate it, then omega is pointing in this direction. So the direction of omega has what, beta? Changed. Direction of omega has what? Changed. Am I right? So when direction of omega has changed, it means what has happened for the direction of omega? Angular acceleration alpha has come into play. So let me solve it very quickly now. It is like v as this speed and it is moving with the v speed, and pure rolling is also happening, bete. Pure rolling is also happening, bete. Pure rolling is happening, so pure rolling can be written as Vc is equal to r omega, general formula. Now listen to this thing very carefully. I have noted in there Vc I am writing here right now, and this one is what? Omega, this one is r. So this is the point of contact. If I see this point of contact, what is the value of V? It is r omega. And if I see this as omega naught and this as what? The Vc, distance is what? R. So I am telling you, bete, this is a wheel, this is the structure, this wheel is rotating like this, and this is the structure. Am I right? So one wheel is rotating around its own axis and other is this structure with respect to which this radius is also rotating. So that rotation of that radius is basically what? Omega naught. That rotation of this radius is what? Omega naught. So it is termed as r omega naught. It is termed as what? R omega naught. I think idea is very clear to everyone. And V is equal to r omega and it is equal to what? R omega naught. And when you are writing some result, so we are getting your omega as r by r, omega as r by r into what? Omega naught. As what? R by r into what? The omega naught. Done? So this is there because this was Vc, this was r, and r omega naught has happened here. That's very simple. Now listen this thing very carefully. We have taken small r as the radius, omega as the angular there, and r omega is there. And when you are writing it for there, now there comes this idea, V is equal to Vc is equal to r omega is equal to capital R into what? Omega naught. And I am writing for omega and it becomes r omega naught by what? R. Now when I am solving this question, so I have seen that alpha I am to calculate, and alpha will be nothing but what? It is nothing but what? D omega by dt. Alpha is nothing but what? D omega by dt. Am I right? When you are writing for d omega by dt, so definitely bete, as I said, when you are rotating like this, am I right? When you are rotating like this, so your omega vector is acting, which kept on changing. So omega vector will be having some omega into omega cap. Omega into what? Omega cap. Because this is a vector. Am I right? And we are talking about the angular acceleration. So when I am writing for it, bete, so d by dt of omega into omega cap plus omega into d omega cap by dt. D omega cap by dt. Am I right? And this omega is given as constant, so it must be 0. So we are getting omega into d omega cap by dt. And this d omega cap by dt is basically what? D omega cap by dt is basically what? It is because this was constant, but it was kept on changing the direction. So when it kept on changing the direction, so whenever any vector kept on changing, so we write its result around which it is rotating. So I can write d omega cap by dt as what? Omega naught. I think idea is very clear. I tell you, when you have any vector is there, this is being rotated, and this is your r vector. This angle is what? D theta. We are getting tangential velocity, which represent basically the direction change, which basically represent the direction change, because it is tangential. It is what? Tangential. So tangential change is happening for you, and this tangential change, which is Vt, is given to you, and it is given as omega cross r, something like that, because Vt is tangential and r vector is kept on changing. So basically change in r vector is represented by the tangential velocity. Am I right? So that's why it is written as omega. If you take the tangential as a cap, which is a direction, so this will be unit vector, so you will be getting omega, and this omega is acting for this. So this is there as omega naught. So we are writing it as omega into omega naught. If you put the values there, you will be getting the final result. I hope you have understood this idea. Very simple idea was there. What was that? Pure rolling was happening. And it was, wheel was rotating like this. Am I right? And what was happening? That one is the pure rolling motion, V is equal to R omega, we have to write VC. And second thought was, it was also rotating about some fixed point. This one was capital R, and it was rotating like this. Am I right? So I have equated these two velocities. Question asked was find alpha, and for alpha d omega by dt is there, and omega vector can be written as omega into omega cap. So why I have written? Because when wheel was here, so it was pointing in this direction, but wheel is also moving in this direction. So first pointing of the omega vector was there. When it has moved to there, then omega vector has been there. So this is the change in the direction of omega vector, because first was this omega vector. When it has moved to there, now this is the position vector, the direction of omega vector. So this is what? The change in the omega vector. And I have written d by dt of omega into omega cap. Question was given, omega is constant, so derivative of constant is what? 0. And we solved omega d omega cap by dt. And this d omega cap by dt is basically omega naught. So that answer is there. I hope you have understood this idea. Now you can solve this option. You can mark the best possible option for you. You will be getting the final answer. Let's move on to next question. That is next dip number 8. It is also very famous question. Everybody is very simple for this question also. Sand falls at a constant speed of mu. It falls on a flat car. So we are having some system here, and this is there, and sand is falling on it, and we are just pulling it up with a force, and it is falling on it, and this is moving with a constant velocity, and the rate at which it is falling it is dm by dt. So what is the force? Force is like V dm by dt, and then in the question dm is given as mu, so we get mu v as our answer. I think idea is very clear. What was there? Sand was there falling onto this flat car. We are pulling it with a force whose force is given by v dm by dt, and dm by dt is what? Nothing but mu, and we are getting force is equal to what? Mu v, and we got this result as the answer, and dm by dt was falling vertically down. Very simple. So I tell you one thing, sand was falling down. What was the initial momentum of the sand? 0. What was the initial momentum of the sand? 0. when it has landed onto this flat car, it has attained the momentum V and the mass. So when you multiply it with that 2, then what we are getting the force, and force is equal to what? F is equal to V dm by dt. What is dm by dt? Mu. So V we get mu V. We get what? Mu V. So that is the answer. Am I right? Mu V, C or whatever the value is given to us. I think idea is very clear. Very simple approach. Sand was falling, initial momentum 0. We are pulling it, then this sand is getting some momentum from this flat car. So flat car is giving that momentum. So who will give that momentum to the flat car so that it can be given to the sand? That is external force. And how much force we should apply? As long as the mass is getting onto the flat car. And that can be treated as what? F is equal to V dm by dt. Dm by dt is nothing but mu. So this becomes dm by dt as force as what? Mu V. That is the answer. So this was our big dip number 8. Now next. This is also a very simple question, very nice question, very good question. I like this question very well. See beta. You have applied the force here. Now listen this thing very carefully. It is also applicable in the laws of motion. Whenever you apply the force on the string itself, then it means that force itself will be acting on in the string. So means you have applied force F, beta. So there will be the force F. There will also be the force F. Am I right? And you consider this length is what, beta? L. So this length is what, beta? It is L by 2. It is what? L by 2. So now you see, he said a pulley is there, massless board. This is a massless board. And length of the board is also given to you. It is pivoted at this point. And there, and a 10 kg block is placed here, and it sits exactly in the middle of the board. So this is just the middle. If it was L, so this must be what, beta? L by 2. And he said that what should be F for equilibrium? What should be F for equilibrium? So I tell you, if you see these options, this looks like very different. So what is 225 by 9? So what is that? Am I right? So I have intentionally, deliberately, I have opted these options so that you should have a habit of calculation. So what do I expect? Because when you will get the answer, then you will be feel low. Oh sir, that was very easy. So I tell you, this force is what? F. This force is what? F. So by this point, let me draw on the next page. Yes. Force F is there, F is there. So you may say this is 2F force. Done. This is what? Mg. Done. This length is what? L. This length is what? L by 2. So we can equate the torque. Mg is applying the torque in this direction, in the clockwise. Mg is applying the torque in this direction clockwise. 2F is applying the torque in the anti-clockwise. Since in the question this is given as equilibrium, so I can write beta 2F upward direction into L is equal to Mg into what, beta? L by 2. L get cancelled. So what I am getting for M? F Mg by 4. So what is the value of M given to me, beta, in the question? Mass of the board as 10 kg. So I will be writing 10 kg into G as 10 by 4, and there you get just writing directly 25. Then you see, sir, in this question 25 was not given. No beta, 25 was given, but the format I have changed. So 25 option, if you divide beta 225, 9, so then you will be getting 25. I think idea is very clear, just writing for the sake of fun, am I right? So this 25, 225 by 9, because I thought if I will give you this question, if I give you this question directly as 25, you will say, sir, it is very easy. So that's why I have given you very simple question, but I have made a change in the calculation so that even getting the final answer very quickly, you should not mark 25 directly, but you should calculate first and then mark the option. Idea is very clear? See, next point. Mechanics tip number 10. Mechanics tip number 10 says what? Says this ball is at equilibrium. So we do know beta, equilibrium means what? Net force is 0. Equilibrium means what? Net force is what beta? 0. When you say equilibrium force, net force is 0, and if you remove, he said one of the force applied by the sphere on the sphere is F. Am I right? And with what acceleration the sphere will move immediately after this particle is, this particular spring is cut. Means there I am having 5 springs and they all are exerting a force such that it is equilibrium is there, and equilibrium means what? The net force is 0. So since I am having 5 springs, let me write in this format today. F1 plus F2 plus F3 plus F4 and plus F5, and they must be equal to 0. So since one of the spring is cut, let me cut this spring. If I cut out this spring, then let me call, I have removed the 5th spring. I have removed what beta? 5th spring. So what I left with here? I left with F1 plus F2 plus F3 plus F4 is equal to what beta? Minus of F5. So we left with that only. Am I right? We left with that only. So what is the value of this force to be conducted beta? You divide it with the mass. Either you take the resultant of these forces by mass, or you take only that particular force by mass. So that will be the acceleration. So acceleration comes out to be what beta? Minus F by m. So this is just a bold character beta drawn in the form of vector. So your answer comes out to be minus F5 by m. So I have taken the force of F5 as F5 as what beta? F only. So I am getting the answer as what? Minus F by m. That's the answer. I think idea is very clear. Very simple. You see, the statement is very big. The things are written very simple, but you have to put your best efforts in understanding this idea. So this was there. 5 springs, equilibrium, cut out one spring, first note down every force, then when the spring which you have cut out, its force gets 0. So you left with only 4 forces, 1, 2, 3 and 4. 1, 2, 3 and 4 you have written, and that was removed. So you made it to the other side, because the resultant of this will be minus of this, because that's why the net sum was 0. So acceleration becomes F by m. I think idea is very clear, beta. Very clear. Now let's move on to next point. Now this is also a very genuine and very good question. Very genuine and very good question. What is that? He said a point source of light is at the center of semicircle, and a semicircular track of radius r, and it's a tangent to the infinite wall, and a block moves around a semicircle with a constant speed v0. So there you are having this bit where it is moving with the speed v0. Am I right? And starting from the tangent point, what is the velocity of its shadow and acceleration on the wall? Means on the wall you have to consider the shadow. Why I have opted this question bit? Because in this question you will be able to apply simple geometry rule, which you know tan theta, sin theta, cos theta we use. Okay, so I will be telling it to you how to apply. Let at any instant this has moved to there. Am I right? So this is rotating with this speed. What is the speed with which it is moving? v0. With what is the radius you have considered here as a circular track radius as r. So what is the value for omega for this instant beta? Omega is equal to v0 by r. Omega is equal to what beta? v0 by r. That is the first thing. So shadow at this point will be moving in this direction with a speed vs. You call vs as a shadow speed. Vs as a shadow speed. And if vs is the shadow speed beta, so if you consider this as a point, and if you draw like this as the value, so you know whenever you are having a circular motion beta, so if this radius, you keep this radius as small r, you keep this radius as what? Small r. So this is the tangential speed. Am I right? So vs is the speed of the shadow, and speed of the shadow along this component theta will be having some component of the speed which will be equal to this speed. Idea is very clear. I am telling you again. Shadow is having this direction of speed, and there you are having a source, and from source to this point beta, you have drawn this value which is perpendicular to it, just like a circular motion, just like a circular motion. So for this speed, just listen this thing very carefully. This arrow which I have drawn, one arrow I have drawn with this wording. I am taking this as r, I am taking this as omega, I am taking this as what? Omega, and this angle as what? Theta. So what is this value for this component? It will be r omega. Very simple beta. Everybody is aware of that speed only. Am I right? And what is the value of omega you have taken? V naught by r. So what is this value? V naught by r into what beta? Small r. That is the first thing. And this is what beta? Vs, and this angle is what? Theta. So what is the component of Vs in this direction? It is Vs cos theta. So what I am doing here, I am just equating the components of the speed, and let me call it as V dash. Let me call it as V dash. So what is the value of V dash I got? V dash will be equal to Vs cos theta. What is the value of V dash I am getting? V naught by r into what beta? Small r is equal to what? Vs to be calculated into what? The cos theta. Now listen this thing very carefully. So we got our answer. Vs is equal to V naught small r by r into 1 by cos theta. Now listen this thing very carefully. Now there comes your answer. You can see this was not also very difficult. This was there. This angle is what? Theta. This is what? R. Just see. Like this. And there we are having r. This angle is what? Theta. This is what? R. This is what? The 90. Am I right? So what we are getting for it? What we are getting for it? Cos theta. Cos theta is r by small r. R by small r. So I can write from there, I can write r by small r as cos theta. So I am getting Vs as V naught by cos square theta becomes secant square theta. What is the value of theta here? Theta is termed as omega t. Theta is termed as what? Omega t. So I am getting V naught secant square omega t. Omega t is what? V naught by r. So I am getting V naught by r into t. Because beta theta is termed as omega t, na? That's why. I think idea is very clear. So this was there. V is equal to V naught secant square omega t. Omega is what? V by r into t. And our question asked was acceleration. And acceleration is nothing but what beta? I am just giving you this an exercise. Differentiated dy by dt of what? D by dt of V naught square. Sorry, V naught. D by dt of V naught secant square V by r into t. Just differentiate it beta and you will get the value of acceleration. So I am just giving you this an exercise for you so that you can solve. I think idea is very clear. So this was your question number 11. Half of the journey is done yet. So please don't forget to like and comment and share. Very important, because we are discussing very, very important questions where we think more mathematics is being used, but it is not mathematics. These are very fundamentals which every person can understand in a very good way, very gentle way, only to apply the fundamentals. Now see this question. He said a force F is being applied on a dumbbell. You applied force on this and you applied the force on this. Am I right? Force you have applied. So when your question asked is, what will happen if you apply a force like this at the two different points of the same body? Where does this bodies will move and what do you expect for the speed or something like that? Am I right? Now listen this thing very carefully. Greatest center of mass speed in where? So it is very simple. Whenever you write anything, because we are having next upcoming question there also, whenever you write any force and speed is asked, then always apply the impulse concept, which is nothing but the change in momentum, which is nothing but the change in the momentum. Am I right? So you have applied force F here, you have applied force F here at there only. So whenever you apply the force F, what happens is that it will translate only, and center of mass will be having F force with acceleration F by 2m for time t, it will be having the same. So in both the cases, what will happen? You apply the force at there or at there, they will be experiencing same acceleration for same time, they will be having the same speed. So your option for this answer is what? They will be having the same speed. All right? This was there. You applied acceleration for center of mass for both the cases is what? Same. And V is equal to what? U plus AT. This is the best part of the rolling motion also, wherever we consider. And since same forces are being applied, so we can say that center of mass will be bearing the same speed. So their answer was D, which was same. Now this is also a very good question. Here, I just want that you should understand this idea. Ram and Sham, they see a trolley which was moving. Ram was standing somewhere far, and Sham was standing somewhere close. That is the only difference. Am I right? So he said that they can see same angular displacement, or they can measure same distance, or they can see same angular speed, and they can see same velocity. Now it is very simple, but see, as I just said in the diagram, they are Ram is at far distance, Sham is very close. So when the trolley has moved from there to there, then what has happened from there to there, beta? What has happened from there to there? What has happened? That they will see the displacements according to their sight. The one which is very close, the one which is very close will see the more change in the displacement. The one which is very far, it will say it is moving very slowly. Now that is a concept, am I right? So you can see, but they will move with the same speed, they will cover the same distance. That is the idea of this concept, am I right? But they will see their angular displacements or angular velocities, they will be different. So that is the answer for it, and that answer is what? Both measure the same distance and both will measure the same velocities, but their angular speeds and angular displacements depend upon the locations of the observers, where they are being placed. So you can see Ram is a bit far, so the Ram will be observing very slow motion of angular displacement, but Sham will experience the more relatively more like the circular the rotation as compared to the Ram. Very simple. Farthest things appear to move very slow, but the closest, when you are very near to watch it, then they move very fast. This was there. The mechanics tip 13 happened. Now mechanics tip, score tip 14. What is that? Very simple. See. He said a ball of mass m which is thrown vertically upward from the ground and reaches a height h before momentarily it is coming to rest. So g is the acceleration due to gravity, and we have to see how much impulse the ball is going to get with the gravity. Just want to make one thing very sure, that you have projected a body up with speed u. So in the question it is asked, it has reached to height h, and when it has reached to height h, he said in the question, what is the impulse the body has received due to gravity during its flight? During its flight means what, beta? It has gone up, then it has moved down, beta. Am I right? It has moved down. So what is the impulse? Now what is the impulse, beta? Impulse is nothing, but we do know it is the change in momentum. And let me write the magnitude only. Initial momentum upward, final momentum is what? Downward. So net change in momentum is what? 2 mu. And since in the question you can see we are expecting our answer in terms of G, H and M. Am I right? In terms of G, H and M. So I am getting 2 mu as my answer, but U can't be written like that. So U have to be written as square root of 2GH. Square root of what? 2GH. So let me bring this 2m inside the square root bit. So it becomes 2GH into 4m square. So we are getting square root 8m square GH as the impulse. This is what we have discussed. Am I right? So this was your question number 14. Okay. Done. I think it's very easy again. Impulse was to be written, and impulse is nothing but fundamental formula as a change in momentum, and change in momentum is what? I is equal to 2mu, and u is what? Square root of 2gh. So we are writing this question like that. Now, this is also a very good question. Very nice question. What is that? Two blocks A and B whose masses are 3m and m, they are connected by a massless cord there, and massless spring is also there. But initially they were hanging like that. Now the string is being cut. When the string is being cut, immediately after that, what is the acceleration? Now the word here is very important. Immediately. The word here is very important is what? Immediately. Am I right? Now see, immediately means, so when this thing was happened, when this thing was happened, so initially, you may note down, initially, what is the value of the spring force? It is upward direction. What is that value? Spring force. Now you see, this was there, this was T, this was what? Mg. So T becomes Mg. And here, spring force, this was 3 mg and this was T, and T is already mg. So what is the force acting downward? 3 mg plus mg. 3 mg plus mg is 4 mg. So spring force is bearing 4 mg force. Am I right? That was initially. I think idea is very clear. This spring is experiencing 4 mg force, and this string is experiencing T, which was equal to mg. Now what is said? Now what is said, bete? This was a spring, marked like this, then marked like this, then this one is break. When you break this up, immediately tension got zero because you have broken the string. So when you have broken the string, what was the force now acting on this block? It is mg. And what is the mass of it? M. So it gets cancelled. So you are getting g as the acceleration due to gravity for the block B, because you have cut out the string, their tension has become zero. And similarly, if you talk about this, and initially the force upward acting was 4 mg, but its mass is now right now downward, which is what? Like 3 mg, and it has to move up with an acceleration a because upward force is more than the downward force. So at particular instant, the word used is particular instant. So upward force is what, bete? 4 mg minus downward force is what, bete? 3 mg is equal to mass of the body into acceleration. So I am getting A as what? G by 3. So acceleration of A is G by 3 and acceleration of B is what? The G. C option I have marked here. So what is the C option? This option as what? G by 3 and G. So that is the answer. I think idea is very clear. You can see the questions are very simple. Very simple questions, I can say. The only thing is we just need to understand in a good way and in a very lighter note. What is that? Blocks, how the blocks are happening and how they are behaving. Apply the very fundamentals, nothing else. Very simple. Now, this is again a very good question. That is score tip 16. Very important question. Very simple question also. What is that? He said a particle slides on a smooth hemispherical surface whose radius is given to you, and what should be its speed at point P so that the normal force at Q equals to weight, means it just reaches. When it just reaches, so it means its velocity must be zero because n was acting in downward direction and mg is acting in the downward directions. Okay, so I think you must have to have this idea. Now what has happened? Now see what has happened. But I just draw a straight line like this. So this angle is what? 60 degree. So what has happened? Because initially this velocity was v and there the velocity become what? The zero. What I can do for it? I can do work energy principle. What it says? Change in kinetic energy is equal to the work done. So how the kinetic energy is changing better? Here the velocity was what? Final 0. Initial velocity is what? V. So what is the change in kinetic energy? Final velocity is 0. Initial kinetic energy half m v square. Am I right? And we are having the work done by the What are the forces involved in it? The only force, one is a normal action and other one is a mg. Other one is a mg. And normal action is doing a no work, only mg is doing the that work. And how about the mg work done? We will see the displacement done in the direction of mg. We will see the displacement done. We will see the displacement done in the direction of mg. So in the direction of mg, bete, what is the displacement done? You can see this was mg, this was 60. So cos 60 is what? 1 by 2. If it was r, if it was total was r, bete, this was r by 2. So this is also r by 2. Because if I am saying this is r, this is cos 60. So this answer will be like what, bete? R cos 60. What is r cos 60? R by 2. So it means body was already at this position. Now body has moved up to there. So how much displacement the body has done in the direction of weight? It is r by 2. So mg is acting in the downward direction, but body is moving up. So its work done will be negative. Mg into what, bete? R by 2. So m get cancelled with m and 2 get cancelled with 2. So v, you are getting square root of minus minus also cancelled, bete, as what? Gr. So g was given as 10. R is given as 1.6. So 10 into 1.6 is what? 16. Square root of 16 is what? 4. So we are getting 4 meter per second as our answer. A. I think idea is very clear now. Hemisphere going up. So what is the value of the, the velocity to be taken? So what was the best point what we have discussed here? It was what is the velocity, and to solve that concept we have used kinetic energy principle. What is that work energy principle? Change in kinetic energy is equal to the work done by the forces. Here two forces were involved. One was normal action, other was mg. Normal action always normal to the surface, so that is not doing any work right here. Only mg is doing work. But by the concept of work, we say work is said to be considered only when body get displaced, and that displacement is in the direction of the applied force. That is the thing. I think idea is very clear to everyone now. So that's why we got this result very quickly, and answer comes out to be 4. Very simple. Now this is also a very amazing question, bete. See, as shown in the figure, the ball is fixed in the block, and then acceleration is given towards left. Then what will be the effect on the normal action? So initially I want to draw normal action will be like here as n1, and normal action will be like here as what? n2, when acceleration was not there. Am I right? And mg was happening to be in the downward direction. Mg was happening to be in the downward direction. Now listen this thing very carefully. This angle as theta. This is there. So this is what we did? n1. This is what? n2. This is what? mg. Am I right? This is what? mg. So since it is being accelerated in this direction, so if we are sitting here, we can apply the pseudo force in the backward direction. Now listen this thing very carefully, bete. If you draw like this as an angle theta, what is the component of n1 here? It will be n1 cos theta. So n1 cos theta is equal to what? mg. So n1 becomes mg by cos theta. n1 becomes what? mg by cos theta. Am I right? And if you see the value of n2, so why I have done the component of n1? Because I am considering my motion in the horizontal and the vertical direction. So in the vertical direction I am having only one force, n1 cos theta. Downward direction as mg. So I have equated them, and you can see with it here theta is taken with this. Here theta is constant, mass, gravity, everything is what? Constant. So normal reaction in this case is not going to be affected. And how to see the normal action for n2? You can see. You can see this is the direction of n1 you consider, beta. Am I right? This was theta. So what is this direction? This direction is n1 sine theta. And this is moving in this direction. And this is moving in this direction with an acceleration what, beta? A. With an acceleration what, beta? A. So what do we write for it? What do we write for it? Force acting in this direction as n1 sine theta plus Pseudo force is also acting in this direction as what? MA, because we set here, we are writing the pseudo force, and equal to the force which is acting on the right side, which is what? N2. Now you can see, initially when acceleration was not there, so N2 was equal to N1 sin theta. But when acceleration was given, now N2 has become N1 sin theta plus MA. Means normal reaction N1 will not change, but N2 will change, means it will increase. So your option for this question is N1 remains same, but N2 increases. See, N1 remains same, and N2 has increased by what amount? MA, because neither theta has changed, nor the mg has changed. Done? So I think this was done. It's a very good question also. Question number, mechanics tip number 18 we'll be doing now. How to solve this? See, this is a very amazing question, so I opted one very good question for you all, so that you can understand this ideas how to solve the concept of river. Now listen this thing very carefully. He says, river is flowing with a speed of 20 meter per second, and a person can swim with a speed 12√2 with respect to the river, and it wishes to reach point B from there to there, and what is the time taken by the person will be. So I have taken this velocity as velocity of the swimmer with respect to the river at an angle phi. So I just want to tell you a very brilliant trick for this idea. What is that? Since we want the resultant velocity in this direction only, am I right? In this direction only. So what I will do, I will take the components of river velocity in this direction, component of swimmer velocity with respect to river in this direction. So you can see the diagram, it will be, I am just writing 20 cos 37 plus V swimmer with respect to river into what? Cos phi. That is a net velocity which is acting in this direction. Am I right? And just to get the final answer, I have to draw a line perpendicular to it. Now there comes a question, sir, why you have drawn this perpendicular line? Because this is the resultant, and perpendicular to that resultant, the component of resultant along this perpendicular line is always what? The zero. Is always what? The zero. So there it becomes So what I am writing here? I am writing here as VSR sin phi in this direction is equal to what? 20. Because 20, this is what? Sin 37. So I'll be writing somewhere here now. I have drawn this line. This was 20. So this answer is what? 20 sin 37. This is what? V swimmer with respect to river with the sin phi, because we have taken this as swimmer speed with respect to r as what? Phi. Am I right? So let me equate these two terms. VSR sin phi is equal to what? 20 sin 37. What is the value of sin 37? You know, this one is 37, 4, this one is 3, this one is 5. Sin 37 is what? 3 by 5, I think. I think it is 3 by 5, am I right? So what is the value of swimmer with respect to river? It is given as 12√2. So I am writing 12√2 sin phi, I don't know. We need to calculate 20 into 3 by 5. 5, 4, 20. Am I right? And you can see 4 3s are 12 and this 12 cancelled. So what you are getting for sin phi? 1 by √2. So what is the value of phi here? It is 45 degree. So you got the value for phi as what? 45 degree. Now listen this answer very carefully. What is the velocity you have calculated here? Let me write here only so that we can answer. 20. What is the value of cos 37? It is something like 4 by 5 plus 12√2. What is the value you calculated for phi just now? You calculated phi as what? 45. So you can write for cos 45 as 1 by √2. So √2 get cancelled with √2. 5, 4 is there. So we are getting effective speed in this direction as 16 plus what beta? 12, which is what? 28, which is what the 28. And what was the length given to you for it? 280 meters. So time taken will be distance covered as 280 by the speed, which is 28. So you cancel it. We are getting your answer as what beta? 10 seconds. You are getting your answer as what? 10 seconds. It's very simple. You know, what we have taken? What we have taken? This is what we have drawn. The effective. We drawn the perpendicular just to get the final answer for the phi. You calculated phi. Then what you have done with that too? You calculated phi. Then you calculate the effective component of velocities in the line joining A and B, and we have taken the ratio of it, and you got the time taken by the swimmer to cross from there to there. I think the idea is very clear, beta. It was very simple idea, very simple thing, very simple approach, very simple. Done? Next. It is also a very good question. A body X moving with the momentum P collides with another body which is stationary. Now see, let me solve this question. This is there and another body is there, and momentum was having P and this was having 0. But when they collided, this body has applied the impulse in this direction and this body has applied the impulse in this direction. So what is basically impulse, beta? I am saying it is in terms of J because we have taken J as impulse, and impulse is nothing but we say it is the change in momentum and it is a vector quantity. Now listen this thing very carefully. What we can write, I have marked the body X, I have marked the body Y. This one is X, this one is Y. So when happened, beta, this remains X, this body remains Y, because when bodies will collide, they won't interchange their names. Am I right? So this is very simple. So what I can say, it was having P as a momentum, and when it collided with that, impulse has acted in the backward direction, and its final velocity has become, you may say, V1. And this body has got its velocity, final speed as what? V2. I think idea is very clear. Yes? Okay. Now listen. V1 is there, V2 is there. So we are getting some response. Nice, very good. Thanks for the support. And I want you should crack the exam. You should feel very happy for it. And I want you should be there with these questions so that you can have the better and best score for you. I just pray for you that you should secure your rank. Score means securing rank. So don't forget to enroll yourself for these different dates we are dealing with. So you should be with the score. Now, listen this thing very carefully. This was P, this was Y, this was X, this is X, this is X, this is Y. So initial momentum was P, this was 0, this has become V1, this become what? The V2. Am I right? So what has happened, beta? What has happened that I will write that equations. How I will write? Now listen this thing very carefully. How I will write? I have drawn this as body A. I have drawn this as body B. So when they are going to collide, beta, they collide like that. Am I right? So this body will exert impulse on the green in this direction. So I am writing the impulse exerted by this on there, and this green will exert the impulse on this in this direction. Am I right? So what has happened here? This was there, and also this was there. Am I right? So what has happened here? Their final velocities has become, you call it as V1, you call it as V2. So final answer what we are getting, what is that? Initial momentum U. So he asked, what is the coefficient of restitution? What is the coefficient of restitution, he asked. Am I right? And coefficient of restitution is given by what, beta? Separation velocities by, with the mod, by approach velocities before the collision. Am I right? So separation velocities are like both are moving in the same direction. So I will be definitely writing V2 minus V1. First thing, and U1 minus U2 as what? The U. Now since in the question he asked in terms of J and there must be P, there must be P, not D, it is P. Okay. So 2J by P, J by P. So we are expecting our answer in terms of J and P. So P was the initial momentum. So I must replace this. So V2, what was V2? What was the initial momentum of it? 0. Impulse has acted as J and its mass is what? M. So V2 into J, sorry. So V2 into mass has become J. This is there, right? J has become, J is equal to what? M V2. And if you talk about this as the impulse for it, so you can replace V2 with J by M. Let me replace V2 with J by M. So this is what J by M minus V1. So what is V1? I will be writing final. What is the final momentum of it? MV1. What was the initial momentum of it? It was MU. It was MU. So where does the impulse has acted on this body? Backward direction, exerted by the green backward direction. So I have to put it as negative because impulse is a vector quantity. So what I am expecting for this result as V1 is equal to, this become what? M get cancelled with M. So this become U minus J. Minus J. So let me put the value. And what is the value of U? You know it is P by M minus J. I think idea is very clear. Now let me put all that stuff here now. V2 as J by M, you calculated. V2 as what? J by M calculated minus V1. V1 as what? P by M. And what was it was P by U and minus J. Am I right? So let me write V1. What is the value of V1? Let me write in the bracket P by M minus J by U. U is nothing but what? P by M. So you can see when you rearrange J by M minus that value and okay sorry, I have to write M here. I have to write M here. Yes, now it's clear. So this becomes J by M minus or minus plus JM This become 2J by M. Am I right? And this become what? Minus P by M. By what? My P by M. So when you take the ratio, so what we are expecting our answer? 2J by P minus 1 as the answer. So this was our dip number. This was our dip number 19. So I think we have dipped a very good way in the mechanics with the dip 19. Done? Now next question. I think idea is very clear. Impulse written, the coefficient of restitution, it should be written in this format only because we are dealing with the vectors. Take the magnitude, we can't take the vectors as the ratio, and impulse format as J is equal to what? Mass into velocity. Done. It is also a very easy question, and this is far common question discussed in generally. Question asked is, what is the value for F by mg and theta? Block is placed on a rough horizontal surface and plank is being raised. This was the horizontal surface and plank is being raised and the angle theta has happened. So what happened after that? Because it is up to certain extent, it will be remaining there, but when you tap, a question will come, angle will come where it is just at the worst to slide down. If you increase more angle, it will slide down only. Am I right? So that is the point. So question asks is friction to the mg. Am I right? So you know, when you are placing this bit, so friction, because you are lifting it up, so it's for sure friction has to act in the backward direction and it is in the downward direction only. Am I right? This angle is what? Theta. This angle is what? Normal action, because we are not doing anything new to it. So we can write friction is equal to what? Mu n, and n is what? Nothing but mg cos theta, because it has a tendency to slide down. So since initially it was mg sin theta, friction was happened to be mg sin theta. Am I right? Friction was happened to be mg sin theta. So what has happened, beta? It has been raised to certain extent, but with the factor of mg sin theta, because until it is sliding, we cannot write any friction, because until it slides, we take that friction as a static friction. We take that friction as a static friction. So that's why beta, it remains mg sin theta as a value, as a variation of friction. So friction has to be like this, and then at critical angle, it is at the worst to slide down. And when it will slide down, it will be the friction will be acting like in terms of mu mg, and then kinetic friction mu k will come into play, and due to which it has to move, slide down with that format. So what we are expecting, sine curve up to critical angle, then get down to 0. Why it is getting 0? It is also very important, because now you have at 90 degree, you have made this plane very perpendicular. So when theta is 0, so normal action definitely has become 0. Okay. So this was mechanics tip 20. Now, this is also a very amazing question. This is also a very amazing question. And what is that? Listen this thing very carefully. See, consider the situation shown in the figure. A particle of mass m is sliding on a smooth block, and neglect the friction everywhere. So the normal action exerted by m on the m at this instant is, see, when you are solving this question, you keep yourself as an observer on there. And when it is said normal action at this instant, because as the block is sliding, the normal action kept on changing. So since it is asked for that particular instant, so normal action has to be acting in this direction only. Am I right? Normal action has to be acting in this direction only. And it is moving here in the direction of V0. So with respect to this observer will see a circular path only. Am I right? This observer will see only the circular path. So what we can see here, n is a normal action which has acted on this. So n is also a normal action which has acted upon this wedge at this instant, which is n. Am I right? So what is the acceleration you are expecting for it? This is n, and this mass of this system of this is what? M. So this becomes what? N by m. N by m as this value, what we have written here. Am I right? And pseudo force will definitely act on it, which will act in the, because this will be accelerated in this direction, so it will be experiencing the pseudo force here only. So what we can write for it? Net force acting towards left side, which is normal action plus what? This force as what? M into acceleration, n by capital M, which is equal to what? M V naught square by the radius r. So when you solve for n, you will be getting this answer. I hope you understood this idea now. It's very simple. What was there? I have marked. What was there? I have marked my observer here. I have taken the normal action here, because this normal action was exerted by this wedge on this body, and this body has also exerted n here as a normal action. Am I right? And this is being accelerated here with an acceleration a. So since we are writing this answer with respect to this observer, which is on the wedge itself, and with respect to wedge, this is moving with the speed what b naught. So we are writing one normal action and other one as a pseudo force, which is equal to what? Which is equal to what? M v naught square by r. And this acceleration was, I have written as normal action which is acted by capital M as the mass of the wedge, is equal to what? M v naught square by r. That is the answer. I think idea is very clear. Though we have taken so much time, but you have seen the questions were very easy, but doable question. This was the pattern of NEET. Okay. Now this is also a very, very good question. It says, for what value of the acceleration A, block slides up the plane with an acceleration G relative to the inclined plane. Relative to the inclined plane. So what is in there, this was there, this was there, this angle theta, and it is said if you should move this acceleration A so that it should slide up with an acceleration which is equal to G. Then how we will solve? If we sit here, then we can observe, with respect to this observer, it will be moving up with the G, because in the question it is said acceleration relative to the inclined plane. So if you are saying this word, using this wording, it means you have to sit inside the plane. So in what way we can solve this idea? In what way we can solve this idea? We can solve this as the block, force has acted like MA, mg has acted like this mg, this angle theta, this angle theta, and this angle no doubt 90 minus theta. So here mg sin theta, here ma cos theta. With what accelerator has to move up? G. So what we can write? Upward force ma cos theta minus mg sin theta is equal to what? Mg. So m get cancelled beta, and what you can write for it, I think you can choose the option, better option now. We are getting a cos theta is equal to what? G into what? 1 plus sin theta. So we are getting a is equal to G 1 plus sin theta by cos theta. What is 1 by cos theta beta? Secant theta plus sin theta by cos theta is what beta? Tan theta. Sin theta by cos theta is what? Tan theta. Am I right? So we get the answer G secant theta plus what? Tan theta. So this was your dip number 2, dip number 22. I think idea is very clear. It's very simple approach beta. You have seen all the questions were doable. All the questions. So I have made my best effort for you all so that we can crack our score exam. That is very important because it is happening on the given dates. Don't forget to enroll to mark yourself. Okay? So this has happened for question number 22. So I'm just giving you this as a homework exercise for 23 to you. You just take a screenshot of it. Okay? So what is there? What is there? Because in this question also, when you solve this question, it is a very beautiful question based on the impulse. I tell you, okay? Based on the impulse. So impulse is nothing but it is the change in momentum. So let's see what is there in the question. A boy whose mass is m standing at one end of the longboat. You have seen center of mass problems. In there, boy was standing on the boat. When boy has moved somewhere here, boat has displaced in the backward direction. That were questions we used to do. Am I right? But here some different wording is there. He said long boat was there whose length is L, mass is given. So when floating motionless on a calm lake, but the boy walks to the other end of the boat and stops. Walked, stops. Then boat moves off for some more time. So when you were standing there, boy was there, he moved, then stopped there. When he stopped there, then what happened? Boat has moved for some more time. He is just assuming that boat has moved for some more time. That is the point. Are you getting? Then he says water resistance was acting, which is directly proportional to the speed of the boat. So as the boy has started its motion, the boat has already getting the displaced. So because of that displacement, the boat has been moving. Am I right? So he said, since you are having this boat beta, it is on the lake, then what has happened? When the boy has moved from there to there, so boat has moved from there to there, so that immediately layers of the water comes into play and they have offered the viscous drag, the force. And that force is directly proportional to the speed of the boat. That force is directly proportional to the speed of the boat. So what he said, what is the displacement of the boat? Right from the beginning. So it's just an amazing question. I advise you, apply the concept of impulse. What is the initial velocity? 0. What is the final velocity again? 0. If initial is 0, final is 0, so what impulse we are expecting? We are expecting the final impulse to be 0. Am I right? And when you are saying final impulse is 0, what was the value of the impulse? Integral force into time. What is the force which is acting, which is proportional to speed of boat? So we can write force, you can write a minus kV because proportionality sign is given, minus kV. So you can write minus KVB into dt. So what is that value? Integral VB dt. So what is VB dt basically? VB dt is what? Integration. Boat speed into time. With integration, we get what? Displacement. Displacement. So since that displacement was equal to what? Now you guess. 0. Because impulse we have written. The time boy has started the motion, immediately the boat rhythm has started the moving in the upward direction, in the opposite direction. So the viscous drag has already started its role in playing in it. Am I right? So that was the point. Very interesting question. So I'm just giving you the option was A. I have solved there also. You just do your best to get it. Okay. This was 23. So I'm just giving you this example, giving you this as a homework. I want you should do by your own. Take a screenshot of it. It's a very genuine question. It's a very genuine question, very simple question. You should do, and you will be able to solve this question very quickly. That is for sure. I tell you what has happened. Just idea, okay? Those small rings are there. They are connected to a block here. They are of length L and L each. Their masses are given to you as M. And initially they were at rest, but when you just dropped it, it has moved down and they have made some angle 60 degree with the vertical. Am I right? 60 degree with the vertical. So I tell you, do one thing only. Work done by the gravity has happened, or you can say decrease in the gravitational potential energy is equal to gain in kinetic energy. That's it. You take the gain in kinetic energy, equate them, you will be getting the answer. So let me help you, because you have to consider when it has moved there, it has moved there, this has moved here. Am I right? This angle, it was there, it was making an angle 60 degree. So it was moving down with the speed VU, it is moving in this direction with the U. So what I am saying it to you, bete, like this. Block has moved in this direction with the speed V. This has moved in this direction with the speed U. So this angle is what? 30. So this angle is what? 60. This angle is what? 30. So the only thing which you should memorize, bete, what is that? You have to take the component of U in this direction. This become U cos 30. And the component of V in this direction, which is what? V cos 60. So both of these components must be equal. Rather, I have solved, because this was why I have equated? Because it is a string which is taut. It is a string which is what? Taut. So since we are having the taut string there, so we have taken the components of its ends along the string to be equal. Am I right? This is a taut string constraint equation where you have taken the components of the velocities along the direction of the string. So you just equate them. So what you can write? You can write loss in gravitational potential energy is equal to the kinetic energy. So kinetic energy of these two rings, ring R1, ring R2, plus kinetic energy of the block. Kinetic energy of the rings will be 2 times half m u square, and for the block it will be half m v square. And you got the relation between v and u also, and you put the value of v somewhere here, you will get the value of u, but you have to work for gravitational potential energy. And it is also very simple, you take this as 0, it has descended down, so this has become what? mgl cos 60. What is cos 60? 1/2 with the negative sign. Am I right? Because it has decreased. So what is the difference? 0 minus there, so it will be positive. So this loss is equal to the gain. Equate, then you will be getting this result, because in the question it is asked what is the magnitude of relative velocity. This is asked. Am I right? So it is very simple. You can approach it with a very simple approach, very simple. So this dip is done. I think you have understood these ideas. Am I right? What is very important for this concept? We have used taut string concept. What is that? Component of the velocities along the string you have to equate. Second concept, the decrease in the gravitational potential energy is equal to gain in the kinetic energy. Who has gained this? One, the rings, other, the block. Write all the kinetic energies there, plus this, you get the result. Done? And this, there comes the last question, which is a catenary problem. So I advise you all, you must do this question so that you can understand. Am I right? This angle is theta, this angle is theta. So let me finish it up. This angle is theta, this angle is theta. So there tension is acting. There also the tension is acting. So you have solved this, their angle, this angle become what? Theta. So what is the component acting for tension here? T sine theta. From the other edge, again also, what is the component of the force acting upward? T sine theta. What is the weight down acting downward? W. So what answer we are expecting? 2T sine theta is equal to what? W. So we got T is equal to what? T is equal to what, beta? T is equal to, so T is equal to what, beta? W by 2 sine theta. That is a T. Now, question was asked, beta, you take a screenshot of it. What is the tension at the midpoint? So we are asking about this point. Am I right? Asking about this point. Now, what we can do for it? See, you mark this point and you focus on there only. So at this point, if you draw the force of tension, it will be acting in the horizontal direction, which is T naught. Am I right? And if you talk about at this end, this angle is theta, beta. This angle is also theta. So this is what? T cos theta. So you know, being a mass here, there is no net movement of this segment in the horizontal direction. So whatever force you apply in the horizontal direction, because this T cos theta I am applying here on the string, because this rigid support is fixing it up like that. So rigid support is having two components of force, one there T cos theta, T sin theta. So I am focusing T cos theta now. So on this string portion, T cos theta is happening there, and there it is happening T naught. So these two forces must be balanced, because this is at rest. This is at rest. So rightward force minus leftward force is equal to mass into acceleration, and acceleration of this portion is what? The 0. So what we can write? T cos theta is equal to what, beta? T naught, and there comes our answer. Put the value T naught. What is the value of T? W by 2 sine theta into cos theta. And cos theta by sine theta is what? Cot theta. Am I right? So we are expecting our result W by 2 cot theta. So beta, this was all about our dip, where I have opted the best ever questions which a NEET student must do. Should not compromise with that. You have to focus on the concepts. You have seen the questions were a bit lengthy in the words, something very confusing in it, but not that much that we cannot solve in a given time. Though explanations were there, some talks were there, so we had gone with the more time with that too, but my prime intention was to make the things very clear to you that doing good level questions of physics is very mandatory, very important for all upcoming exams whatsoever you are preparing for. So don't underestimate, don't go for the formula based. Now the best part, you have seen this thing, whatever questions I have solved, we have not used any formula. Like it means you put this formula, you put that formula. No, we have framed the equations, we have seen what is there, what is not, what is required, what should we attempt. That is there. I think idea is very clear to everyone now. And see, so let's end up with this session with these 25 questions. And if you have not subscribed our channel, just follow it so that you should not miss next session, which is happening in the very next week. You will get every update of it. And if you need any support from our side, just drop a comment to us. We will definitely respond to you and help you to crack the score exam, because our main priority is the score exam. So again, score exam is happening with this cause for you, for your dreams. so should not miss this out at any level. Yes, and when you are going with that too, so finally the session is being concluded, so I must say like, comment and must subscribe our channel. Don't forget bell button, it is very important. And you have to register with this, because if you want such type of questions, you want, because final our result is waiting for us is the NEET, so we want to crack our NEET exam. These questions were very mandatory, and don't forget to enroll yourself with this link, very, very important. And as discussed earlier also, it is just an appreciation for you all, so that you can crack, you can understand the things in a good way, and you feel very good about it, that physics is one of the easiest subject for the NEET students. I can say, I usually say to my students, beta, NEET physics is one of the easiest. Only thing is you just have to pace up. Nothing worry. Just read and write. That's it. So this is all about Score 2025. Don't miss out. Very important. And eligible for 3rd to 11th. Online, offline modes are there. And registration is also happening 28th September and 12th of October. I can say golden chance not to miss out, because India's topmost students has already enrolled and they have started their working. Still few days are left, but you can make of it. Don't forget. And then dates are there. Whenever the last submission is there, wherever the exam center has been allotted, everything you will get by mail and by any support from our helpline number. And don't forget duration, as discussed earlier also, you were having that too. And don't forget again, like, comment and share, because next session is going to make you very strong with the strong mental ideas and the thought processes. And must follow us on Instagram, subscribe our channel, Telegram, join us like on the Google Pay, get it on, and don't forget to follow us on Facebook. So this is all about for today's session. Very thankful to you. God bless you and best of luck for your SCORE exam. Thank you.